In this second segment of volcanism in our history, we'll explore the 1783 eruption of Laki in Iceland and its impacts on the northern hemisphere. Iceland is a land of fire and ice, of volcanoes and glaciers, but with relatively few people. Only Greenland has a lower population density. Geologically, Iceland is a hotspot located in a divergent seafloor spreading zone. The hotspot raises the seafloor spreading zone above sea level, while the spreading motion explains the long fissures and valleys that cross the island. The west half of Iceland is part of the North American plate, while the east half is part of the Eurasian plate. And Iceland is the only country in the world that can consistently expand its territory without taking land from others. Iceland continuously grows as magma rises along rifts to form new land. Because magmas at divergent boundaries generally have low silica content, their viscosity is low and they flow easily. So pressure does not build up to dangerous levels, and Icelandic volcanoes tend to have relatively safe eruptions, dominated by quiet lava flows rather than violent ash flows. The sort of eruptions, like those at Hawaii, where you can take photos of yourself by magma and still be around to find out what your family and friends think of the photos. So how did this happen? And by this, I mean this eruption, which I cannot even begin to pronounce, that occurred from March through May of 2010. It was an eruption violent enough to generate its own lightning storms. Well, that's what happens when you mix a volcano with a glacier. The heat from the volcano melted the overlying ice, so rising magma met with water to create violent steam eruptions, also known as hydrovolcanic eruptions, that shot magma up into the air to cool as volcanic ash. These ash particles, although small, are hard, and they can melt to play havoc with airline engines. Combine that with the fact that the airspace around Iceland is a very busy air traffic corridor, and the result was chaos. Billions of euros were lost until the ash began to dissipate, and European governments rewrote their safety regulations to allow planes to travel through low levels of ash. But 2010 was not the first time that an Icelandic volcano ended up affecting much of the world. One of the more important things to remember about volcanoes is that although volcanism tends to be very local, its impacts can be regional, or in the case of violent, sulfur-rich tropical eruptions, even global in scope. Why? Well, because a volcano is not just magma coming to the surface, but gases as well. And although most of the gas is steam, it is not just water vapor that's being vented. In a similar way, neither was all this magma and water vapor when it erupted. All the land surface, as far as you can see, formed from volcanic lava that erupted over an 8-month period beginning in June of 1783. Immense lava flows covered agricultural fields and filled river valleys. Yet not a single person was killed by the lava flows. Despite their size, the eruptions were not terribly violent and were dominantly lava rather than ash. Yet thousands still died. How? Well, lava covered fields to destroy crops and pasture. Since this was 1783, there wasn't any way to bring in enough food for people and livestock. As a result, famine occurred. But again, Laki did not just erupt lava and water vapor. Laki's magma was particularly rich in sulfur dioxide and hydrogen fluoride. The sulfur dioxide combined with water to produce acid rain that devastated any crops that were not covered by lava. As bad as that was, the hydrogen fluoride was even worse. Fluoride-rich ash covered the grass to poison livestock. 4/5 of the sheep that Icelanders relied on for food were lost, along with half of their cattle and horses. The result was a fourth of Iceland's population starving to death during what appropriately became known as the mist hardships, the mist being the volcanic gases that directly or indirectly led to starvation. But the effects of Laki's eruption extended well beyond Iceland. That same fall, Benjamin Franklin was in Paris, serving as an American ambassador to negotiate and sign the treaty with England that would end the Revolutionary War. However, Franklin still found time to pursue his passion for science. Like others, he noticed an unusual haze that blocked sunlight to the extent that he could not set a piece of paper on fire using a magnifying glass. Although no one on the continent knew about Laki's eruption yet, Franklin suggested the haze might be from a comet's tail or an Icelandic volcano. More importantly, he suggested the haze might be the reason for the unusually cold winter that occurred that year across Europe and North America. But even Franklin limited his conjecture to Europe and North America. No one considered the possibility that Laki might somehow be affecting the whole northern hemisphere. Nor were they quick to realize Laki's haze did not just block the sun. Across Great Britain, over 23,000 people died from breathing Laki's poisonous gases. Most of those victims were people suffering from weak hearts or respiratory ailments. And Laki caused crop failures and hunger across Europe and eastern North America. However, its effects extended even further. A dry fog was reported across the Altai Mountains and over central China. While in Alaska, Laki's haze had the greatest impact on the Alaska tree ring record in over 9 centuries. Inuit along the coast have oral traditions of a time that summer did not come, and tales of villages that were devastated by famine. But volcanism does not occur in a vacuum. Other processes were in play at the same time. An unusually strong El Niño event began in 1780, and the combination of El Niño and Laki weakened monsoon systems to create drought in India, causing the Kalisa famine that resulted in 11 million deaths. In a similar manner, a weakened monsoon system in Africa led to drought there that caused Egypt to lose a sixth of its population, and Tunisia a fifth of its people. In Japan, this was the time of the Great Tenmei famine, which was also partially due to the contemporaneous eruption of Mount Ozma. The result was a loss of population that in some areas would not be recovered for 100 years. No one in Iceland died in the lava flows, not a single person. Yet millions died worldwide as an indirect result, and history changed. In France, Laki initiated a period of bad crops and famine that was extended by El Niño in the years to follow. The combination contributed to social unrest that ultimately resulted in the French Revolution. Even for big volcanoes, Laki was unusual. Most climate-changing eruptions occur above subduction zones, where silica-rich magmas fuel eruptions that are so violent that they can eject gas aerosols high enough to reach the stratosphere, from where the aerosols spread out across the globe to act as a veil that decreases sunlight to affect climate. So how could a relatively quiet eruption in Iceland end up affecting most of the northern hemisphere? Well, the catch is that the stratosphere isn't as far above the ground in high-latitude locations. At the poles, it's barely 8 kilometers above the Earth. So Iceland's high-latitude location made it easier for Laki's gas aerosols to reach the stratosphere to affect climate. Laki was the first time that people began to suspect volcanism's potential impacts on regional climate change across Europe and North America. But its global impacts were not recognized at the time. No one considered the possibility that a volcano could possibly affect climate on the other side of the world. Not even 3 decades later, when an Indonesian volcano completely eclipsed Laki's effects to impact the whole globe. We'll explore that eruption in the next segment. In the meantime, if you're interested in learning more about Laki's eruption, I would recommend Witze and Canopy's Island on Fire. It's a well-written and well-researched book that covers the eruption and its broader impacts.